All right, so here we are with another practice problem. I hope the first one was easier for you to understand, especially because it dealt with a zero initial velocity that you were used to with free fall. So now here's our second problem that you are going to work along with me. So let's go straight into it. We have a rocket ship that undergoes an acceleration of 112 meters per second for a period of 8 seconds. Knowing the rocket began with an initial velocity of 1,000 meters per second, how far did it go during the 8-second period of acceleration? So once again, let's take a look at our question. The question says, how far did we go? How far did the rocket ship travel? We're looking for some type of distance. So yay, we have another straightforward equation, meaning we don't have to solve for none of these, we can just solve for D. That's what I mean by straightforward equations, okay? We have an 8-second period of acceleration. So even though you see it twice, you only need to count it once, okay? And you're gonna come across word problems that can be a little wordy. You just have to be able to filter out what's important and what's extra information. So our time is 8 seconds. Here is something else that's straightforward in the problem. Knowing the rocket began with an initial velocity of 1,000. It tells you right there, word for word, initial velocity of 1,000. And we know this, okay? So our VI is going to be 1,000 for my units, meters per second. Distance, we're looking for some number in meters. I got to get into the habit of writing units as well, just like you have to. Then we look at the first sentence. A rocket ship undergoes an acceleration of 112. It's telling you exactly what this number represents. Acceleration of 112. So once again, the same strategy. Nowhere in this problem does it mention final velocity, nor does it imply or read between the lines anything regarding final velocity. So I'm going to cross it out. Now we're just going to plug in and solve. D equals BIT plus 1/2 AT squared. B, we don't know. My initial velocity is 1,000. Time is 8. And I like to keep my numbers in parentheses based on the variable that it represents. It just helps me keep my calculations organized. Do what works best for you. For the sake of putting my numbers in the calculator, I changed the 1/2 to 0.5. My A acceleration is 112. And I'm making sure to put this square for our time inside the parentheses. So that way, if you put it all in your calculator at one time, your calculator is going to recognize that the 8 only needs to be squared and not this whole entire section. Okay? So take out your calculators. If you're fancy, you probably have a calculator. And if you're like me, you have it on your phone. So I have 1,000 times 8. No need for a calculator. If you don't need it, don't use it. That's 8,000. For this, I do need the calculator. 0.5 times 112 times 8 squared. And if you know what 8 times 8 is, it's 64. That's the second part. 0.5 times 112 times 8 squared, or 8 times 8, which is 64. So this particular section of our formula is 3,584 plus 8,000 11,584 meters. Get used to seeing big, funky numbers, okay? You may have some extreme decimals, you may have some extreme large numbers, you may also have numbers that don't make sense. That's okay, because what's most important in physics is you understanding the process, how to solve it, the strategies, and the fact that we're looking at constant acceleration. Okay? The next thing you're going to do is a set of practice problems on your own. It's going to be a mix since today is Friday and we're just going to do everything for the week into one assignment. So the next assignment will have equations for the big equation number one. There's going to be free fall questions that you will have to solve, and then also the concepts that you must understand, and then practice problems for equation two. Next week, you will look at equations 3 and 4.